are on homework. What would you like clarified? Alec?
Number 3.
Number 3, do you know what that is?
Yeah, pull up the book, sorry.
Somebody have
We're finding the cube roots of 8.
Wait,
Cube roots of 8?
it was 3 and 4. Not 5.
3 on homework board?
Oh, on 4, I was looking at 5.
Yeah, thank you, Rick.
Wasn't that 46?
Number 4?
No, we're looking at 4.
Homework 4 was 4 times.
It's express z equals 1 minus I in polar form. And then show z to the negative 1, z to the 0, z squared, z cubed, z to the 4th, z to the 5th, z to the 6th, z to the 7th, and z to the 8th in argument form.
So we may just get the idea of this and go on. So the idea is we're going to find these in polar forms. We want to put them in that cis form, r cis theta. And then we're going to graph those, and you'll see something kind of cool, I think, that happens out of that. And I don't know if I'll go all the way to 8, but we'll do a few of those. Okay. So I'll do z to the 0 because I just need to warm up. Anything to 0 is 1. Got that. Good. Okay, let's say z to the 1st, we know that. Oh, no, I guess I got to put it in cis form. I better put this in cis form too. Well, think Argonne diagram. This is how I do it. Real, imaginary. There is 1. And so it's r, the distance from the pole is 1, its angle is 0. So we think of that as 1 cis 0. Okay, so for z, we need the r, and that's going to be the square root of 1 squared plus 1 squared. So that's going to be square root of 2. Is that all right? And so z to the 1st is going to be square root of 2. And now we need the angle. So I'm going to go here. I think I can get away with just looking at the graph. So 1 minus I is 1 in the real direction. Negative 1 in the imaginary direction is going to put us right there. And we can go either this way, or maybe it would be better to go that way. I don't know. So can you tell what that angle is?
Negative 1 over 4. 7 pi.
7 pi over 4. Or negative, you said negative pi over 4. Yeah. So either cis negative pi over 4 or cis 7 pi over 4. Or you could do degrees. It doesn't really matter. Is that okay? So let's do the 1 over z, which is our z to the negative 1. So we could do it a couple of ways. We can do it, I think it's easiest just to make the 1 in, which we already know what that is, in cis form, divided by the z, which we just got in cis form. Does that make sense what I'm saying? So this is like 1 divided by z.
Yeah, mostly my problem was like graphing.
Oh, graphing.
Where my problem was, yeah.
Okay, okay. Well, let me get, do you know what these are? Did you get those correct?
I did negative 1 over square root of 2 cis pi over 4.
Okay, hold on a second. So z to negative 1 is 1 over square root of 2 cis pi over 4. Sounds good. Did you get z squared?
2 cis negative pi over 2, or 3 pi over 2.
We'll call 3 pi over 2. This is good. Oh, we did great. This is the hard part.
I do like argument cubes.
Yeah, let's go to z to the 4th anyway. That will be enough. We'll get the idea. So this is going to be what, 2 square root of 2
Yes, cis.
cis
7 pi over 4.
7
Or
pi.
no, 5 pi over
5 pi over 4. 5 pi over 4 sounds better. Let's go one more. Z to the 4th is 4 cis.
4. Negative or pi.
What is it?
Pi.
Pi. Just pi? Okay, so let's graph at least all of these on the same axes. I'm going to do them in the order, so we'll do them in the order like negative 1, 0, z to the 1st, and then so on this way. Because I think when you see it in order, you kind of see what's happening. So z to the negative 1 is, where did we say that? Well, oh, right here. So that's going to be 1 over square root of 2 cis pi over 4. So pi over 4 we know is on this angle right here. And now square root of 2 is like a little bit bigger than 1, because square root of 1 is 1, square root of 2 is like about 1.4. So 1 over square root of 2 is going to be a little less than 1. So I'm going to arbitrarily choose 1 to be like about that distance there. So this will be a little less than that distance on that angle. Is that okay? Then z to the 0 is just 1. That's 1 cis 0. So now we're going to be along, here's our angle 0. So this was theta is pi over 4. This is theta equals 0. And now we're going to be at distance of 1. So this is supposed to be a little bit longer than that. Now z to the first is right here. So now we're in a distance r of square root of 2, and now we're at an angle of 7 pi over 4, or we said that's also negative pi over 4. So here is our theta equals 7 pi over 4. That is going to be kind of subtle. So this is 1 right there, and we're going to be about 1.4, so that's a little bit further away. So now we're here. Is that okay? Then z to the second, now we're 2, and that's at 3 pi over 2. So here's our angle, theta equals 3 pi over 2. And now I'm going to go, if this is 1, and I want to go 2, it's going to put me about there. Okay, and then we're going to be z, well, we have to z to the third, 2 square root of 2, and 5 pi over 4. So the angles are kind of nice because you get this really nice incrementation that we're seeing. You're going to click, 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 click over this way, always going 45 degrees or pi over 4. Now 2 square root of 2 is going to be a little bit bigger then, so that's going to be like 2 times about 1.4, so now we're about 2.8. So I'm going to imagine, there's 1, 2, almost to 3 is going to be right here. Is that okay? And now z to the fourth is at pi, so now we're out here, and now we're going to be 4 away. So there's 1, 2, 3, 4. We're going to be about there. So what you're hopefully seeing, kind of see the pattern emerging there?
Yes.
So you're spiraling out here, and what happens is that whatever that first angle was, and this might have been nice to think of as negative pi over 4 in this case, because really we're going, because anything to 0 is going to be 1. And whatever that first angle is to z, in this case it was a negative pi over 4, then every time we multiply by z again, so z squared multiplies the z to the first by z, z cubed is going to multiply the z squared by z. Each time we multiply by another z, we're going to add another angle of negative pi over 4. So they're going to be spaced evenly. And the r is going to get multiplied by another value of r each time. So in this case, square root of 2, each time we multiply our distance by square root of 2, which because it's a little bigger than 1, it's going to get a little bigger each time. And so it lies on this big spiral that's going to keep getting bigger and bigger and bigger. So if you had an r value, it's kind of interesting, because if you had an r value of 1, you're always going to stay on that same circle, and you're just going to keep rotating around. If your r value is bigger than 1, your spiral is going to get bigger and bigger and bigger. If you had an r value of less than 1, then each time you multiply, you're going to get smaller, a shorter r. You're going to spiral into the pole. Does that kind of make sense?
Yeah.
So they either grow and expand, or they shrink, or they, if they're 1, they just stay where they are and move around that circle. It's kind of interesting, I think, these different powers of complex numbers. Good question. Others?
11 on homework 5.
Number 5, number 11. And you know what that is?
Yeah. So factor z to the fourth plus 4 by writing it as z to the fourth plus 4z squared plus 4, all that in parentheses, and then minus 4z squared.
This? Oh, this thing squared minus
No.
4. Is that right?
No, it's just minus 4z squared.
This was to put 4 on the 4z and not the parentheses.
Yeah. It's a difference of 2 squares.
Oh, yeah. Minus 4z squared. Like that? So the idea, yeah, and you're going to see it as a difference of two squares, because this is really z squared plus 2 squared. Is that okay? And now we're going to think of this as a difference of two squares. So this is a squared minus b squared. So we're going to factor into a minus b and plus b. So there's your a, z squared plus 2 minus b is going to be a minus 2z, right? Is that okay? And then a, which is z squared plus 2, plus b, which is going to be plus 2z. And maybe we want to rearrange that so it's z squared minus 2z. Z's and 2's are dangerous for me. And then z squared plus 2z plus 2. Okay, that's not the end of the story though, right? Was there more?
And then use part A to solve z to the 4th equals -4.
So now we want z to the 4th
And plot the roots of the equation.
equals -4. Plot the roots. So use this to solve for that. Is that right?
Yeah.
Let's see. So that we want to equal, so setting this equal to 0 is going to lead to this. We want to solve that by solving this.
That's what it says.
So, because we can do this two ways, I think what they want us to do. So we could do this like what we've been doing with de Moivre's theorem, right? So we could say there's going to be 4 complex zeros of -4. And that's a bunch of what we've been doing in the homework. Now, what they're suggesting is, let's do this a different algebraic way. So we're going to take this thing and factor it in a crazy way to here. Is that okay? Now, these two quadratics are multiplying to be 0. So we learned in your Algebra 2 days how to solve a quadratic. So either this is 0 or that's 0. We're going to use the quadratic formula here, and we're going to get 2 answers to that. We'll do the quadratic formula here. We're going to get 2 different answers. Those 4 answers are going to be what we could have done using the whole r cis theta thing and de Moivre's theorem. Does that make sense? Which I kind of like that way. I think it's cooler. I think this is just going to grind out quadratic formula. Okay? So I'm going to say, that one's going to be the orange. So we get z equals -b plus or minus the square root of b squared minus 4 times 1 times that is going to be times 4 all over 2a. So that's going to be 2 plus or minus the square root of 4 minus 16 is going to be a -12. Well, we knew we were going to get imaginaries, right? So we're going to get 2 plus or minus. We can think of the square root of -12, remember, as -4 times 3. And the square root of -4 is, okay?
I'm a little confused
Oh,
on where you got the 4 up top.
So,
I saw the 4 minus -4. Where'd the 4 come from? Where the
so this is b squared minus 4ac.
4 AC? Where does the 2 come from?
Not 4, how about 2? Does that
Okay.
sound better?
Yeah.
Well, it's arithmetic. Okay, how about 4 minus 8? That was better?
Mm-hmm.
Okay, well, I knew something wasn't computing there. Now we can say the square root of -4 is 2i. And now we can split that up and say it's going to be 1 plus or minus I. Okay, so there's 2 of those 4 zeros. Now we're going to take this one and do the same thing. So z equals -b, -2 plus or minus square root of b squared minus 4ac. This time I'll use the right c all over 2a. Is that okay? So we have -2 plus or minus square root of that, and again a -4 all over 2. So that's going to be a -1 plus or minus I. So there's your 4, 0, or 4, I guess, fourth roots of -4 we found without having to do anything with our polar, cis, all that stuff. Oh, I think the polar way is a lot cooler. That's what they're trying to lead you to there. Anything else? All right, well, what I want to do today is actually it's a pause, and we're going to kind of review the stuff that's in chapter 11 in our book here. But we're going to go on and do chapter 12 starting on Tuesday, and we'll test on both of those together on Friday, September 18th. So to do this, I thought we could do, if you have particular problems you'd like to do or kinds of problems you'd like to do, we can do those. Otherwise, I have a list here we can do as well. I thought for sure we should probably do the equation conversion, because I think that's really challenging, and maybe do some graphing that we didn't really get to do much of in class. And I thought we might as well bring you up to the board to do this. So I'm going to put an example up here, and you can, if you don't come in front of the camera, and I don't know if anybody's really dying to get in front of the camera, then I can, when I post it to YouTube, I can put it on the public domain. And if one of your vulnerable faces shows up here, then I have to do it on the private domain. So it might be just easier if you stay out of the camera, and I'll work it with you but on camera because I have no vulnerability left. Okay? Okay. So let's start with converting. Let's convert the equation r equals 3 sine theta to rectangular coordinates. And we're not going to be able to socialize. Go ahead and come in here. I just put on the private one. It doesn't really matter. But I think we should try to at least honor the social distancing here of 6 feet if we can.
Can I steal this jar?
Yeah, oh, anything. Now, what you take is what you're going to use all day. So at the end of the day, you can go put it, and I'll go sanitize it. But just keep that one so we won't share chocolate. Colton's got a great idea. I think that's the strategy. So sine theta by itself, we don't really know how to convert that to rectangular. But if we could make it into an r sine theta, we're in business. So we multiply both sides by r. I thought that was what you're doing, but maybe I didn't see it right.
Got a little confused.
I was wishing that's what you were going to do.
Let's just figure it out, right?
Okay. Now we got to think, what's our conversion? What is that r sine theta? Do you remember? Yes. So we know that r sine theta is y. Now, do you remember what r is, and therefore what r? Yeah, you got it.
Okay.
So we know that r is the square root of x squared plus y squared. So therefore, r squared is going to be. You're good. I mean, either way. Once you get to here, we're in business. Hopefully, you recognize that. Maybe not. Do you recognize what that is?
A circle?
Yeah, it's going to be a circle. Yeah. And we could do more, do the square and find out what the center radius is, but that's good enough. Okay, so let's do another problem here. See, let's do, this time we're gonna convert, so we will convert, x plus 2 squared plus y squared equals 4 2 polars. So you want to get rid of the x's and y's, make them into r's and thetas.
Should we square this out?
Yep, you're gonna have to square it out, sadly.
So, almost as if we just tried to reconstruct the problem.
You would think so.
Okay. Oh, so that's just gonna be r squared equals negative 4x.
Now you just got to get your hands dirty there and trade the x's in for r cosine thetas and the y's in for r sine thetas, unless you can very cleverly recognize there's an x squared plus y squared there.
I missed
Colton was
that.
very clever over there.
You are very smart.
But you can do it without that. So since you started down the path you did,
I jumped in the hole.
gather the terms, Austin, that have r squareds in them and factor the r squared out. I think it won't be as short as Colton's, but it will be, you'll have some fun that you won't get to experience.
I don't remember how to find theta.
No, so we have now, so you can either call this r cosine theta squared, or you're trying to jump to r x squared.
That's what, yeah, that's what I was doing.
X squared plus y squared is r squared.
Oh, it's
X.
And the x is going to be r cosine theta.
okay, and then
So this, the x here, we're going to call r cosine theta.
Then divide both sides by r. Sit down.
No, I mean,
Here. You're short, I can't remember.
Oh,
I can't remember that we could do that.
Yeah.
So r is negative 4 plus negative. Yeah, I was right.
So our goal is to get r equals something that has just thetas in it.
be surprised how many points that is. That is probably 30% of my cross points last year.
I'd say like 80.
So we're getting to there? Yep. That's our goal. Then you can divide an r out. And I think that, yeah, see where it
You
should
still
have been
waited for you
negative.
to finish to check your answer, so.
Because yeah, okay.
Yeah.
Good to go.
You didn't do it yet.
Okay. All right. Let's graph.
This is nice, it's all at the board.
I know.
All right.
Let's see if we can graph. Let's say r equals
It's better than the board.
True.
3 sine 2 theta. And you can name it also. So do you know what the name of that is?
Is greater than b.
It's a limestone.
Actually,
Or is it a?
a limestone is going to have
Oh,
something plus or minus. So it's going to be some kind of rose curve.
Oh, okay,
It's
so
going to be
it's
a
got
rose curve.
4 petals.
4 petals because you have sine of an even number times theta.
It's
Yeah.
gonna start here.
Well, let's see. So where's
the
it
yellow.
first? Yeah, there you go. So
So it starts at,
U equals pi over 2.
because that's when sine is equal to times.
Oh.
So then,
so when that's an even number, we get twice as many petals.
so it's,
So we have 4 petals. So we want to know where the end of the first petal, will be when sine 2 theta is first equal to 1, which is the largest that a sine can ever be. Yeah, so you got it. So sine of pi over 2 equals 1, which means 2 theta is pi over 2, which means theta is going to be pi over 4 is the end of the first pedal.
Dude, I actually really enjoy these.
In prep, I hated these.
No, I meant, I hated graphing them, but doing the curves was always
Yeah,
fun.
So the largest this will be is going to be 3. So I'm going to put kind of as a boundary a circle with radius 3. So
Look
at
at
the
that.
angle
Ow.
pi over 4,
I never really learned.
we're going to get
This always frees out.
Oh,
our first pedal.
So
Okay.
with your thing. Oh, I
Now the pedals are going to be evenly spaced. So since we said there's 4 pedals, then we can say the spacing between pedals is going to be 2 pi, whole circle,
Well, let me guess.
divided by the number of pedals, which means every pi over 2.
It's cool.
So from the pi over 4,
Label your points.
the next pedal we're going to add pi over
So
2.
when we're doing these forms, do we have to specify that part right there? Instead of just evenly spacing them? Do we have to specify what the spacing that they need?
Yeah, I'd like to see that, how you're coming up with that. So that'll be our next pedal. And then we'll take the 3 pi over 4 and add another pi over 2 to that to get the next pedal. Very good 4.
How'd you get the spacing? Oh, you just divide 2 pi
2
by
pi
12.
by the number of pedals.
Okay.
Do it. And then we'll add another pi over 2
So
to
who's cosine?
that.
It'd be 0.
Okay. So they're just looking for normal weight.
Yes.
Okay. So if it's sine, it's pi over 2. If it's cosine, it's 0. And then you just divide by
And then you divide by thetas.
And we're going to start at the first one, flip 180 degrees, go clockwise through the pole, and it goes. And then through the pole.
You did it backwards.
Doesn't matter where you start as long as you end up in the same place.
I don't know.
Some were better than others. Okay, so you have something else?
Sure.
Okay, heard a definitive yes, please. That's what I like to hear. My selective here. Let's do r equals 3 minus 4 cosine theta.
Now we got the,
We're graphing now, yeah.
We're going to graph it again. Now, what's this going to be? And you can name it also.
Okay, B is less than A. I mean, A is greater than A. So,
I cannot remember like any of this.
You don't remember this? So you're going to plot your quadrantal angles. So if it's something like A plus or minus B sine or cosine theta, that's going to be what we call a Lima zone.
1,
And anytime we graph a Lima zone, we're
7,
going to plot the quadrantal angles. So we're going to find out what is R, and theta is 0, pi over 2 pi, and 3 pi over 2. And then from there, we're going to think like Doppler radar and try to sweep from one of those x or y intercepts to the next. Now, on the rose curve, I wouldn't say try to put the rectangular coordinates because it's just too messy. I would do label the angle and make sure we can see what the R value is. But on Lima zones, we should label them the rectangular coordinates. So even though you use theta and r to find them, you should label them using x and y's.
Okay, wait.
And we're going.
I think of it. And this is
Oh,
forward.
it's,
Yes, so when theta is 0, cosine of 0 is 1, so we get 3 minus 4 times 1, 3 minus 4 is negative 1. So we'll go to, oops, I put that in the wrong place. When theta is 0, we get negative 1. So that's going to put us right there, and we'll label it negative 1, 0.
This is a loopy boy, right?
it is a loopy boy.
So looped leave us on. Leave us on with an inner loop. So when pi over 2 cosine is 0, so the r is going to be.
You're supposed to,
Yeah, I guess
that.
1, 2, 3.
General gist is there.
All that
do you
0,
think
comma
they'll take
3.
it if I call
Because
it
we're going to label it
loopy
using
boy?
rectangulars.
Loopy loop.
Pi cosine is negative 1, so it's going to become 7. Instead of 0 here. Ours should be 7. Okay, so pi will be all the way over at 1, 2, 3, 4, 5, 6.
Loopy boy, wait.
We'll label it in rectangulars as negative 7, 0.
Yes.
And 3 pi over 2 cosine 0 again, pi is going to be 3 again. So 3 pi over 2. So starting at the r is negative 1, going to a positive value, you have to go through 0 somewhere on our path. Then we will go to a bigger positive, to a smaller positive, and now we're going from this positive 3 back to a negative 1, so we go back through the pole. So it's called a looped Lima sum.
Yeah, that's like. So,
Or Lima sum with an inner loop.
It's a majority. We're rounding up.
It's a majority.
We're rounding all
Let's do one more, whoops.
Do you think they'll take the name of Loopy Boy?
Loopy Lima sum.
Loopy boy.
Loopy Boy.
Do r squared.
No.
9 sine 2 theta.
Oh, these are the cool ones.
These are the cool ones.
And they're easy to draw.
They are easy, I will grant you that.
This is just a thing out for you.
Yeah.
Do you remember the name of this?
This is
No.
a Venus code.
I just know it's a figure 8.
Yeah, it's a figure 8.
It's called a lemniscate.
Lemnis, yeah, I was close.
Nope.
I was supposed to be new with your, it's a figure 8.
Yeah, well, I was right. You were wrong. I was right. I just wasn't right in the right way.
So the biggest sign can be as 1, which means the biggest, the right side, and the equal sign can be as 9.
Yeah.
So the biggest r can be as 3.
Yes.
So we're going to put a circle of radius 3 as our boundary.
It's going to be 5 over 2. Divided by 2. So yeah.
It's going to be a figure 8 or a propeller blade, whichever way you want to think of it. The question is, where is sine 2 theta going to be its biggest? It's going to be where this is oriented. And since sine of pi over 2 is 1, that means that 2 theta must be pi over 2,
Okay, boy.
which is going to tell us that theta is pi over 4. So our lemniscate is going to be oriented, we say, on the line theta equals pi over 4.
I don't know how you guys remember this. I don't remember any.
I just remember the.
So there's some homework, I think, wasn't it?
Yeah, it was the first one.
So then it's going to be a little wider and fatter than a rose curve. It's going to be a big figure 8 or propeller blade. And that's the end of our story.
Trust me, I didn't do good on these in prep. I didn't do good on anything in prep.
You were finding your way in prep. You found yourself an AP Calc. Okay, so let's say that X
Oh,
is 4 times cosine of 2 pi over 3 plus I sine 2 pi over 3. And Y is going to be, let's say, 8 times cosine of pi over 6 plus I sine of pi over 6. And can we first find X times Y? And I think we can do it in both polar and rectangular if I constructed this the way I hope I did.
Making me better than that one, just 6.
And you know also wants to do it rectangular.
Yeah.
So
2 pi over 3, so that's, I'm just solving. Oh, no. So 4 times 2 pi over 3.
Why am I doing that? Scratch that. Or we just call it 4. 6 pi over 3, huh?
oh shoot.
It's pi over 6. So to multiply, we'll just multiply 2.
I found the coordinates of X and Y.
that's what I did.
I didn't need to, because we're doing.
Oh, we're finding X times Y.
4, 6, 5,
That's nice.
6.
Um, 5 pi over 6, so
Oh wait, I thought you wanted us to like multiply it in rectangular.
No,
So
no,
we
no,
did
no,
it
no,
with
no,
this.
no, 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 no,
I was like, this is.
no, you want your
fun.
answer? No, no, I'm sorry. I misunderstood you there.
I think that's.
No, put it in the forward. That's forward.
I like that.
Okay, yeah, I agree.
Okay?
Oh, you went over X.
Because I can.
Oh,
Oh, rectangle. Dang it! Let's see, 1 4 times
Either of those versions is good for the polar form.
Yes.
I should probably circle the answers.
I should too. See, there's two kinds of people in this world. There's people who draw the box, and then there's people who split it into two.
You split it, how dare you?
I do split it into two.
At least you're not a circler.
Circles.
We agree, negative 1/8 minus square root of 3 over 8I. I like it. Also about.
This was always my country.
This is gonna challenge time-wise. This is the one my gal asked about to begin
I
class.
had the whole thing. I feel like everyone else was too scared of it.
I really wanted to use the chalk like that.
No.
Oh, you had the sharp ones.
Our class was a whiteboard class.
I always had the chalkboard class. Aha.
Oh, cis 0.
What?
Cis 0. 1 cis 0.
You're right.
Oh, x2. X1
4 plus 4, 12, 16. Tangent of negative square root of 3, so that should be 3 over 3.
16. Inverse tangent. There's no pi over. No? Okay.
What?
I was pi over 4. Oh, that's 1 over. So that's one. No, it's just one. It's just 1. No, 1 over square root of 3 is pi over 6. 1 over square root of 3 is pi over 6.
1 over 3.
1 over square root.
1 over square root of 3 is pi over 6, yes.
What was saying?
Dude, I gotta say Oregon Hall alone. You know I'm having one of those days.
Okay.
Oh. How did I put a dot in there? How did I miss my axis?
Just the axis. I don't think you can get plus here. Because this is like pi over 3 to pi over, you can keep adding negative pi over 3s.
I was supposed to put my 1 here, and then I somehow put it here. I was like, how did I miss the axis?
Think of this, I think it's easier to think of that as a negative.
These problems always seem to do that.
Wait, you just heard that.
How are you doing over there?
Fine, never mind.
Negative. That's about 60 degrees.
That looks alright. Me trying to draw graphs.
That's okay, I'm just gonna say that this is 64.
What's the graph you want me to do? Oh.
That's
and say x to the 0, so here's x to the 0. This is first,
Let's say 4 is right there.
x to the
And 16 is right here.
and
No.
to the so that part of a big spiral that's growing.
Is there any way you can graph that on polar form?
Yeah, I think you can actually. I have to think, I don't know. Maybe not. I feel like there must be a way to graph the spiral. I'm not sure. Seems to be R equals something theta.
Yes.
Is that okay? Alice?
Well, I also know that this is basically the same distance.
Well, we're about out of time, so I'm gonna stop our video here.
Oh, we're still recording.
Hoping that the video is still running.
Cool, we're already famous on
Are we supposed to give you our chalk?
If you can put it, there's a little like plastic box there.
Used chalk.